Crank angle sensing uses information on the speed and position of the crankshaft to control ignition timing and injection sequencing. The control unit can then trigger the ignition and injection to suit operating conditions. The position sensor may be mounted externally on the crankcase wall, or it may be inside the housing of the ignition distributor. There are different kinds of crankshaft position sensors. Inductive type sensors sense the movement of the ring gear teeth on the flywheel or a toothed disc on the crank pulley. These sensors do not make physical contact. The sensor is mounted on the crankcase wall. It consists of a stator with a central permanent magnet and a soft iron core surrounded by an induction winding. The housing around all of these components is insulated from them. The stator is positioned so that it has a very small clearance or air gap between the end of the soft iron core and the flywheel teeth. As the flywheel rotates, the teeth approach and leave the stator, and the air gap changes. As this occurs, the strength of the magnetic field changes. The winding is part of a complete circuit, so changing the magnetic field produces an alternating voltage and current. As the tooth approaches the stator, the strength of the magnetic field is increasing. This induces a voltage and current flow in the winding. The polarity of the voltage is said to be positive, as it produces a current flow in the winding in a certain direction. When the tooth aligns with the stator, the magnetic field is at its strongest, but at that point it is not changing. Voltage and current flow fall to zero. As the tooth moves away from the stator, the strength of the magnetic field changes again, and once again voltage and current flow is induced in the winding. This time current flow is in the opposite direction, and the polarity of the voltage is now said to be negative. Since polarity changes every time a tooth approaches and leaves the stator, the voltage produced is an AC voltage, and the current flow in the winding is an alternating current. Similarly with the toothed disc. As the tooth approaches the stator, the magnetic field is changing. It reaches a maximum when the tooth aligns with the stator, then changes again, decreasing as the tooth moves away. An alternating voltage is produced. It's the frequency of this alternating voltage that's used by the control unit to calculate engine RPM. Crankshaft position is detected by a separate sensor, also an inductive type. It sends a signal to the control unit when a pin or bore passes and generates 1 pulse per revolution. It signals the control unit that the number 1 piston is, for example, 80 degrees before top dead center. Ignition timing is then decided according to the operating conditions and triggered to occur a certain number of degrees from that point. When only one sensor is used, the pulse inductor is shaped to provide information on both crankshaft speed and position. A disc attached to the crankshaft pulley has a number of equally spaced ribs around its circumference, but 2 ribs are omitted. The frequency of the pulse from each rib gives engine speed in RPM, but on each revolution the pulse alters as the gap from the 2 missing ribs passes the sensor. This again gives the position of the number 1 piston.